Hi, in this video what we're going to try and do is add a microphone to the sound to light input on this Aurora LED kit that I built in a previous video. So I did mention towards the end of that video that I was probably never going to connect this to my hi-fi, but it might be nice just to have as a visual effect in the background. So what I've done is bought this little microphone module. It's got an electric microphone on the front, and then just on the back it's got a MX-9814. So this MX-9814 is a microphone amplifier with auto gain control, and then it's got adjustable gain on the output buffer here, which you can set to 3 levels, which I think are written on the PCB. So you can set the gain to 60, 50 or 40 dB by either setting the gain pin to VDD, ground, or leaving it floating. So we'll probably end up going for maximum because it's probably going to be a fair distance away from me. I'm going to have this up on the wall probably. But this MX-9814 is suitable for supply rails up to 5.5 volts. So this hopefully should be a really straightforward modification, because all we're going to do is connect the supply rail and ground, and then where we've got the microphone output, this has a DC bias on here. So what we'll do is on the back of this PCB where we've got this capacitor down here, it's also on that multi-purpose USB input. So the USB input had the 5 volt and the ground, but it's also got this audio input with a DC blocking capacitor. What we'll do is we'll try and desolder that and connect the end here onto the audio output on the microphone module, and then what the aim is that it will sit probably just in the center here with some double-sided foam tape or something, and hopefully that will give a nice visual effect. So we'll probably start by adding the double-sided tape to the little PCB so that it's in place for soldering. So I've got some foam tape, which hopefully will do the trick. I don't know how old this is, so it may have sort of gone past its best. That's a little bit too big. So we can push this onto the back here. See if we can peel this off. Let's see if it'll stick just here. That seems like it's done the job. So the next thing that I want to do is try and lift this capacitor and probably just rotate it 90 degrees. So I've got some interesting projects coming up on the channel. The first one that's going to appear is a lighting controller, which is something that I'm building for the house. And this is going to be a highly configurable sort of main board with plug-on modules to configure the operation. So we're going to go through the design and development of a trailing edge dimmer for dimming mains powered LED lights. There'll be a module for controlling 12 volt or 24 volt LED strips, and then probably modules just to provide relay control to turn things on and off. So that one's going to feature hopefully in the next month or so, and then there'll be 4, 5 or 6 parts to that as we develop each of the modules. And I'll be sourcing PCBs for those. JLC PCB have offered to supply those to me for the channel, so may as well take them up on the offer. And in between those videos I'll probably do some product reviews and general electronics teardowns. And there we go, I think that's it. So we can try powering this up now. I'll just tidy up the desk a little bit and then we'll have a look at what it does. Right, so what was supposed to be a fairly simple modification has now turned into about an hour and 20's worth of debugging. So the first thing that happened is when I connected it up to the USB port, the USB port just turned off and the device didn't work. And it turned out there was a dead short between ground and VDT, and after taking off most of the components on the little add-on board, it turned out that it was a solder bridge on the MX-9814, but it wasn't visible from the outside. So I did have to take off the MX-9814 with the hot air gun, clean up the area and then put it back on, and then it was working. So assuming you arrive with a fully working microphone board, what you actually need to do to get it to work, because once I connected it all back up again, the lights just weren't doing anything relating to the sound that was going on. And I think what was going on is the auto gain control is just too aggressive on this chip. So what was happening was it was trying to increase the gain when the sound levels were very low, but it was so aggressive that you know, just between saying a word, it had already increased the gain so much that all of the LEDs were still lit. So it was just kind of flickering around like this the whole time. It was picking up background noise and everything. So in the datasheet there is a explanation of how to disable the auto gain control, and what it says is this TH pin needs connecting to the mic bias pin just here. But basically what I did there was just remove R2, and then it's just connected to mic bias through this 150k ohm resistor. And that seems to have done the trick, but that was quite a lot of faffing around to get that working. So I hope you enjoyed that video. I think that's quite a nice little modification to this, much better than having to plug in the device to your hi-fi, and now it means you can use a standard USB cable because it hasn't got that strange configuration of using one of the data pins. So you can just use a normal USB cable and plug it into to any USB power supply. So there we go. Until next time, thanks for watching.